Okay, today we're doing 3.4, solve rational equations and inequalities. So by the end of today's lesson, you should be able to solve rational equations and inequalities. And the first thing you want to be able to do is distinguish between an equation and an inequality. Because when I presented the notion of solving polynomial equations and polynomial inequalities, it was in two separate lessons. Today I'm going to throw it all at you at once. But there is a very big difference between solving a rational equation and solving a rational inequality, just like there was for polynomial equations and inequalities. So of course you know that an equation has an equal sign, and you know that an inequality has one of these signs instead of an equal sign. Okay, so let's look at this list of to-dos here. To solve rational equations algebraically, you need to factor the expressions in the numerator and denominator. You need to state restrictions. You need to rearrange and combine the equations so that there's really only one rational expression on either side of the equal sign. And then once that's done, you can really just cross multiply to solve, okay? Which is the same sort of as multiplying both sides by the factored denominators, okay? All right, so let's do an example of solving a rational, a rational equation. All right, we've got this. This is a rational. This is a rational because it can be written as just 2 over 1. And so to solve a rational, go back to our steps. We have to factor numerators and denominators. Well, this is all in factored form already. You can't simplify this anymore. And so all we're going to do now is state restrictions. So I'll just start by putting a little colon here. The only restriction that I can see is that x cannot equal 5, right? Okay. Cross multiply and we get 2 times 5 minus x equals 6. That's super easy. It's like grade 10 or grade 9 all over again. 10 minus 2x equals 6. Minus 2x equals 6 minus 10. Minus 2x equals minus 4. What's happened to my hands? And x equals 2. So the solution to that particular so this particular one is x equals 2, where x cannot equal 5. All right, let's do the next one. This time around, there's a couple things we can do. We can either use our knowledge of adding rational expressions, which you learned last year, and can get this one side to be a single rational expression. Or I think more easily if we just move one of the terms, because this is really comprised of two terms. There's the plus sign separating these two terms. If we move one of the two terms to the other side, then we can cross multiply. So let's just do that. I think that's easier than adding or subtracting, adding these two rational expressions together. I think I'm tired. I'm not talking well tonight. Okay, here we go. I moved the x to the other side, and now this is just like x over 1, right? And we're going to cross, wait a minute, before we cross multiply though, I got to state my restrictions. So I have a restriction really coming out of the bottom that says x cannot equal 2. Okay, now I can cross multiply. X times 1 is x. Negative x times x minus 2 is really just negative x squared plus 2x. Now how am I going to solve this for x? This is a squared. I've got an x here, and you know that solving a quadratic really means getting it so that one side equals 0. Actually, I'm reneging on that. I'm just going to erase that. I don't like using negatives, so I'm going to move the x squared, the negative x squared, over to the left-hand side and have that side equal to 0 here. So x squared plus x minus 2x equals 0. And so when I combine these, I'm going to get x squared minus x equals 0. And as long as I have one side equal to 0 now, I can solve this by factoring, right? X times x minus 1 equals 0. And so my two answers here are that x equals 0 and x equals 1. And we always have to double check that we haven't come up with a restriction as one of our solutions. If it was, then we would have to reject it because we know that x is not allowed to equal 2. So our solutions are that x equals 0, x equals 1, where x cannot equal 2. Okay, so let's just review. All we're going to do is get one rational on one side, one rational on the other, state restrictions, cross multiply, double check our restrictions, and we've got our final solutions. Why don't you guys pause the video now and try this one. It's not that tricky, really, but I mean, obviously it's a little more tricky. Don't forget you have to factor top and bottom before you state restrictions. Okay, so pause the video and see how you do. So if I state restrictions, which I'm going to restate at the end, but I'm going to put them in at the beginning. Wait, I can't do that yet. I have to factor everything first. So 3x minus 1 over x minus 3, difference of squares here, times x plus 3 is equal to x plus 1 over 2x minus 7. Okay. Now that I've factored, I know that x is not allowed to be plus or minus 3. So that produces a 0 down here. We also have that x cannot equal 7 halves over here, right? So if you don't know how to get the fraction restriction, you can just take that bottom there, set it equal to 0, and rearrange to solve for x. Okay, so those are the restrictions. So now that I've done that, I'm going to cross multiply. I can't cancel anything up and down, but if I could, I would. So I'm going to cross multiply, and I'm going to get 3x minus 1 times 2x minus 7 on this side is equal to x plus 1 times x minus 3 times x plus 3. Now, just like I factored this, I'm going to have to now expand this because I need to get this everything over to one side. So let's start by FOILing this side. So this is 6x squared minus 21x minus 2x plus 7 is equal to, well, let's start by just getting this back. So this is x squared minus 9. And then let's gather these like terms. 6x squared minus 23x plus 7 is equal to, now we're FOILing again, x cubed minus 9x plus x squared minus 9. And these are all different terms. So let's see, the x cubed is positive on this side, so let's move everything to the right. So I'm going to end up with 0 over here, and I'm going to end up with x cubed. I'll gather up the terms here, so let's put plus x squared there, and let's put minus x squared here from over here. And now if I gather up my x's here, I've got a minus 9x, and when I move this one over, it's positive 23x, and then I've got minus 9 and minus 7. So far so good. Alright, probably running out of room here, but anyway, oh no, got lots so far. Okay. Gathering this up a little further, this is going to be minus 5x squared plus, what is that? 16, 14x, and then minus 16. And you guys are just going to let out the biggest groan here, but what we have to do now is factor this cubic using the integral zero theorem. So you're going to find your b's that are factors of negative 16, unless we can group this or something, but no, we can't. So this is going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. Those are my options. Do you think 1's going to work? 1 minus 5 is minus 4. Minus 4 plus 14 is 10. Okay, that doesn't work. Minus 1 might work. Let's think. Minus 1 minus 5 is minus 6. Minus 14. No, that's not going to work. All right, let's try 2. I'm doing this all in my head. You can do it with your calculator. It's all fine. So this is going to be 8 minus 20, which is minus 12, plus 28 is, oh, looks like 2 is going to work. So I can say P of 2 is equal to 0. So x minus 2 is a factor. Okay, so now I have to do my handy dandy synthetic division. Ooh, I didn't leave much room there, did I? So 1 minus 5, check for missing x's, but it looks like I got them all. And let's see, I'm just going to use a red pen here. So bring down the 1, minus 2, bring that, or subtract those two, that's going to be minus 3. This minus 2 times minus 3 is 6. Subtract those, you get 8. 8 times minus 2 is negative 16, and you get 0. So that's good news. Since we knew it was a factor, our remainder should be 0. So now we've got, so far, x minus 2 times, from here, x squared minus 3x plus 8 is equal to 0. Now remember, our job was to solve this. So as soon as we can solve it, we're done. So we know that one of our solutions is x equals 2. And another of our solutions is, I don't know, are there two numbers that multiply to 8 and add to negative 3? I don't think so, but maybe there are. Maybe there are roots, maybe there aren't. We should use b squared minus 4ac again to just check that. So b squared minus 4ac is going to be minus 3 squared minus 4 times 1 times 8, which is equal to 9 minus 32, which is equal to what, 23? Minus 23, sorry, which is less than 0, so no roots. And that means the root, or the solution to this, is x equals 2. And if we go back and check what our restrictions were, is that one of them? No. So we can say x equals 2, where x is not allowed to be plus or minus 3 or 7/2. Okay? So as long as you show me that solution, you're good. Okay, that's solving rational equations. It's not that difficult, and it's using a lot of what you already know. Okay. To solve rational inequalities, it's a completely different methodology, and you need to recognize that because it almost looks like you can cross multiply this, and if you do that, trust me, you're going to get no marks on a question. So really pay attention to what the sign is between these rational expressions. So the first thing it says is factor the expressions in the numerator and the denominator if they're factorable. Rearrange them and combine them so that your one side is 0. And then you're going to set up an interval table, and it says using the zeros and the vertical asymptotes as your intervals, and then you're going to test to see where the function is positive or negative. You've already done this, right? We've already set up the table to check for positivity and negativity, and so now this is the same idea, because if you've got less than or equal to 0 on one side, you're really just checking to see what whether your rational is negative or not, or whether it actually equals 0. That's important when you have the equal sign. Okay, so let's look at this first one. This first one, really, I didn't leave you any room. That wasn't very nice of me. So let's see. Oh, gee whiz. We don't want to move on yet, do we? Did I skip a page here? Yeah. So unfortunately, I didn't give you much room, and I'm going to just maybe do it over on the side then. I'm not ready yet, because what I have to do here is I have to... My pen's going crazy. That's not where I wanted to go, but anyway. So what I need to do here is I've got x over x plus 1, and I need to bring the 5 to the other side, because this right-hand side has to be 0. So now I've got less than or equal to 0. So now, I know another big groan, you're going to have to do your addition of rational expressions here that you did last year. So remember, you're going to find a common denominator, in this case x plus 1. You're going to multiply your numerator by whatever you have to multiply this denominator by to get the common denominator. So in this case, it's 1, so that's awesome. So you just have x here. And then over here, you've got minus 5, but that has to be multiplied by x plus 1 to get the common denominator. So it's going to be minus 5 bracket x plus 1. If you don't put the bracket in, you're going to be in trouble, okay? Because you would just be... you would have minus 5x plus 1. You'd have the wrong sign. Okay. I should probably, at this point, before I do any more combining, just make sure I've stated my restrictions here. So you can see on the bottom, we can't have x equal to negative 1. How about I put it up here where there's more room? X cannot equal negative 1. So, let's get back to simplifying this. So this is going to be x minus 5x minus 5 over x plus 1 is less than or equal to 0. So x minus 5x is minus 4x minus 5 over x plus 1 is less than or equal to 0. I want to just go back, because it happens to me so much in this course that... a student might look at this stage. They found the common denominator and they've adjusted their numerators accordingly, and then they cancel like this, and they're left with x minus 5. You cannot cancel these. This is not common on the top, so you cannot, unless it was in both of them, you cannot cancel the x plus 1. There is a minus sign here. If there was no minus, if this was just 5 times x plus 1 on top, then no problem, cancel on the top and the bottom. But if there's two terms like this, unless that factor is common in both of the terms on the top, you cannot cancel it. So please don't make that mistake. Okay, so remember what we did for positive and negative intervals. We had to find two things. We had to find the vertical asymptotes, which I will find right now, and we had to find the x-intercepts. So the vertical asymptote, well, that comes out of being 0 on the bottom, so x is equal to negative 1. This is not where we say not equal to, because we want the equation, the actual equation of the asymptote. So that's x equals negative 1. And then the x-intercept, recall, the x-intercept occurs where y equals 0, and the x-intercept of this function, if it were y equals, would be, if I took this and set it equal to 0 and solve for x. This whole thing has to equal 0 on the top in order for the y value to be 0, which is the case for the x-intercept. So if I rearrange this, I'm going to get minus 4x equals 5, and x equals minus 5 over 4. So I've got these two things to consider for my intervals in my table. So let's go back to my blue. So my interval is going to be from negative infinity. Which number is smaller, negative 5 over 4 or negative 1? We're going negative 5 over 4. Then we're going to go from negative 5 over 4 to negative 1. And then we're going from 1 to infinity. Okay. I'm using round brackets for everything right now, but we're going to go back to that And you'll see what I mean in a second about that. So now we're just going to go to this equation, not our original. We're going to go over here and we're going to break the top and the bottom down into the numerator and denominator. So there's the top, the bottom, and this is minus 4x minus 5 over x plus 1, or you could write f of x or something like that. And then this is our result column. So we are trying to figure out, and maybe if we put, it might remind you less than or equal to 0 if I just write that in. So our result needs to be less than or equal to 0. We're taking that from here, right? Okay, let's test. So right here, negative 100. I put in negative 100 for x here. That's positive 400 minus 5. Well, I know that's positive. Negative 100 plus 1, I know that's negative. I know a positive divided by a negative is a negative. Is that the result we want? Less than or equal to 0? If I have a negative result, golden. From negative 5 to negative 1, so for negative 5 over 4 to negative 1, I would strongly suggest you use you change it to a decimal. It's probably the easiest way to do it. And so negative 5 over 4 as a decimal is going to be negative 1.25. And we're trying to find some number to test between negative 1.25 and negative 1. So how about something in between, like negative 1.1? So if I take negative 1.1 and multiply it by 4, negative 4, sorry, I'm going to get positive a number less than 5. Positive 4.4, in fact. Minus 5 is negative. Negative 1.1 plus 1 is going to also be slightly negative. So therefore, when I divide those two, I'm going to get a positive. We want our result to be less than or equal to 0, so this one doesn't work. Let's test 100 here. Put 100 in here, we get a negative. Put 100 in here, we get a positive. We divide a negative by a positive, we get a negative. And yes, that's the result we want. So, to solve, let's just conclude there. We would have that therefore x over x plus 1 is less than or equal to 5. Now consider, just make sure that's right, yeah. Now consider the intervals that we have, which are from when x is an element of negative infinity to negative 5/4, and we want this one as well, negative 1 to infinity. The problem is that we have less than or equal to 0. So we are allowed to equal the 0 in this case. Okay? This function is allowed to not just be negative, but it's also allowed to be at 0. Which one of these numbers here, negative 5 over 4 or negative 1, represented the 0? You can see that it was the negative 5 over 4. So, when x is an element of negative infinity to negative 5 over 4, including the negative 5 over 4, because we are allowed to have it, and then we're going to go from negative 1 to infinity. Now, should we have a square bracket here? That negative 1 represented the vertical asymptote, and we're never allowed to touch the asymptotes. So we would continue to have a round bracket here. Okay? So this is very, very important that in these types of examples, when you're doing the rational inequalities, we can potentially have a square bracket. You really have to go back and consider, did I have an equal sign? If I did, I need to include my zeros. Which ones were my zeros? Okay, that's the thought process. So yes, x is less than or equal, x over x plus 1 is less than or equal to 5 when this is happening, and we can still have our restrictions, which were that x cannot equal negative 1. Okay, and we can see that x could not equal negative 1. It's okay. That's not part of our solution, but we're putting it back in anyway just to be on the safe side. Alrighty. Do we have any more examples to do? Oh, look at that. Okay. Do you feel brave enough to try this on your own? give the lesson or the video a pause and try it on your own and come back in a second and see how you've done. Okay, so I'm back. I'm going to factor the top and the bottom so I can get my restrictions. So this is going to be x minus 2 times x minus 1. Goodness, I'm so tired tonight. Over x plus 4 times x plus 5 is greater than or equal to 0. So I can come up with my restrictions. X cannot equal negative 4 and x cannot equal 5. You could have just negative 5. You could have just listed them. Sorry. All right. So now what we're going to do at this point is we've got everything that we need. We don't need to rearrange this any other way. We can, if we could cancel things, we would, but that would create potentially a hole instead of an asymptote, so be careful about that, but we will learn about that tomorrow. So right now, this is as simplified as it can be. We've got one side of the inequality that has a 0, so we're good to go. What we need to do now is identify those two things again, the vertical asymptotes, and in this case, we have two of them. So the vertical asymptotes are x equals negative 4 and x equals negative 5. Okay, so I've got two vertical asymptotes. My x-intercepts are going to occur where this top is equal to 0. And so if I set this equal to 0, I get two zeros at x equals 2 and x equals 1. So I'm going to have a whole bunch of intervals here. Let's start with the smallest one. So this is going to be from negative infinity to negative 5. And then from negative 5 to negative 4. And from negative 4 to 2. Not 2, 1, hello. And from 1 to 2. And last but not least, 2 to infinity. I'm just going to see if I can move this. Oh, not wise. Okay, I'm just going to change my view. Give me a sec. Okay. So the last one there is 2 to infinity. Okay. And then the top, 2, 3. Okay. So I'm going to write this as x minus 2 times x minus 1. So I've just taken the whole numerator. Gonna take the whole denominator. It's spilling over here. This is going to be the whole thing, so we could call this f of x because I don't have enough room. And we want our result to be greater than or equal to 0. All right. We're just testing again. So that looks like a negative infinity, although there's a little tail on that. So negative 100 again. Negative 100 times negative 100 minus 2 is a negative number. Negative 100 minus 1 is a negative number. When we take a negative times a negative, we get a positive. Negative 100 plus 4 is negative. Negative 100 plus, I can't even read my own writing, what is that, 5? That's a negative, and a negative times a negative is a positive. But when I divide two positives, I get a positive, and that is the result that we want. Between negative 5 and negative 4, let's say negative 4.5, put that in, that's a negative, together they multiply to a positive. Negative 4.5 plus 4 is negative, and then negative 4.5 plus 5 is positive. So a negative times a positive is a negative. When I divide, I'm going to get a negative, and no, that's not what we want. Between negative 4 and 1, well, that's 0 falling in there, so this would be a negative times a negative, which is a positive, and a positive times a positive, which is a positive. And a positive divided by a positive, that's a positive. And is that what we want? Yeah. Between 1 and 2, 1.5 minus 2, that's a negative. 1.5 minus 1, that's a positive. So a negative times a positive, that's a negative. 1.5 plus 4, that's a positive. 1.5 plus 5, that's another positive. So a positive times a positive, that's a positive. When I divide those two, though, I get a negative. And that is not the result we want. And then if we're going to infinity here, let's pick a big number like 100. 100 minus 2, well, that's positive, and that's positive, so two positives multiplied is a positive. Oh, sorry, hopefully my husband will get that. And then 100 plus 4, that's a positive. 100 plus 5, that's a positive. Those are both positives. And when you divide that, you get a positive. That is a result that we want. So we're going to summarize here, and we're going to say that x squared minus 3x plus 2 over x squared plus 9x plus 20 is greater than or equal to 0 when x is an element of. Now, we got to think square brackets. Remember where the square brackets go? They go around only the zeros. So only the 2 and the 1. Okay? So we're going to choose these three intervals, but only square brackets around the zeros, not around the asymptotes. So negative 4 to 1, square bracket, and 2, which is a square bracket. That's a square bracket for the 2 to infinity. Sorry, I've got that wrong. Don't I? No, I don't. Sorry, I'm looking at the... So let's just double check this. At the 2 and the 1, we should have square brackets. So there's a 1, square bracket. There's a 2, square bracket. We've got round brackets at the negative 5 and the negative 4 because those were the vertical asymptotes and you never actually touch those. Okay? All right. That's good. We are, I think we might be done. Let me just go to the next example if there is one, and I think we're good. Oh, it's too good to be true. Okay. So, resist with all your power the temptation to cross multiply. If you cross multiply, you will get very few marks for a question like this. As soon as you see that inequality sign, you cannot cross multiply. You have to move everything to one side so that one side is 0. So you're really testing for positive or negative. So I'm going to start up here. X plus 3 over x is greater than, and I noticed I went back and played the tape and it was making these clicking sounds, and that's so annoying. So I will try to fix that for the next video. I updated the software and something must have changed. Okay, so I've got this. I'm going to put everything on one side. Minus x minus 2 over x plus 1. Okay. Is greater than 0. Now, I'm going to combine these. The common denominator is x times x plus 1. The common denominator is not x plus 1. This x is not a factor of x plus 1. So you have to have both of these together as the common denominator, the lowest common denominator. So what do I have to multiply x by to get x times x plus 1? Well, obviously x plus 1. So that's what I have to multiply this numerator by. So x plus 3 times x plus 1 minus, this is x plus 1. What do I have to multiply it by? X. And I'm going to put in x minus 2. I'm multiplying that numerator by x. And all of this has to be greater than 0. Okay. Oopsie, I can't put equal signs there. What am I doing? Alright, so now I've got to clean up this mess, and I'm sorry there's no room here. Let's just go ahead and FOIL this. So this is going to be x squared plus x plus 3x plus 3 minus x squared plus 2x when I expand this out. Oh, it's supposed to be a straight line. x times x plus 1 is greater than 0. All right, on the bottom then, we're going to, or on the top, we have x squared plus 4x. So we got rid of the x squared, and we've got, what's this, 4, I can't even read my own writing. X plus 3x is 4x, 6x plus 3 on the top, and x times x plus 1 on the bottom is greater than 0. Okay, I didn't cancel anything. I should probably have stated restrictions somewhere along the way. So let's just look. Our x cannot equal 0, and it cannot equal negative 1. Alrighty, let's keep her going here. So I've got this rational, I've got a linear in the top, I've got a quadratic in the bottom. So I still have to find the vertical asymptotes. So I know those already. Those are x equals 0 and x equals negative 1. I'm going to find the x-intercepts, which are going to occur up here when this is equal to 0. So that's going to be x equals negative 1/2. Again, if you just want to look at the math behind that, that's 6x plus 3 equals 0. 6x equals negative 3, and x equals negative 1/2. Okay, there's only one x-intercept in this particular graph. Okay, so we're going to make up our intervals then with the smallest numbers. So our first interval, of course, starts at negative infinity and goes to our smallest number, which is negative 1. Then we're going to go from negative 1 to negative 1/2. Then we're going to go from negative 1/2 to 0. And then we're going from 0 to infinity. I'm not sure why there's that extra column there. I believe that's an error. Okay. We've got our function, which is 6x plus 3, and x times x plus 1. That's our denominator. We'll just call it f of x. And we want our result to be greater than 0, right? We're looking here. We're going to test negative 100. That result is negative. Negative 100 times negative 101. That's positive. When we divide, that's negative. Is that the result we wanted? We wanted the result to be positive or greater than 0. No. Negative 1 to negative 1/2. All right, so that's going to be negative 3/4, say. So negative 3/4, you got to be careful here. Negative 3/4 times 6. That's going to be a number bigger than 3, but it's negative. So that's going to still be negative. So negative 3/4 times positive a quarter is going to be a negative number, and when we divide those, we get a positive. That's the result we want. From negative 1/2 to 0. Oh, okay. Well, what about negative 1/4? So negative 1/4, a quarter of 6 is going to be less than, a quarter of 6 is going to be less than 3. So it's going to be positive here. And this is going to be negative 1/4 times a positive, which is, again, a negative. And when we divide that, that's negative. The result then, no, we don't want a negative. From 0 to infinity, we're going to have 100. If we put 100 in, that's positive. If we put 100 in here, that's positive. And when we divide, we get we get a positive. And the result is definitely one that we want. Okay, so let's summarize. We can say, we can go back to our original equation, which was not so nice. We'll just put our answer in blue here. So therefore, x plus 3 over x is greater than x minus 2 over x plus 1 when x is an element of which one? Negative 1 to negative 1/2. Now, Nothing has square brackets here because this sign was the greater than sign here, right? It wasn't an equal sign on the bottom. If it was an equal sign, then we'd have to consider the square brackets around the x-intercepts, but because it's not there, we don't. So it's -1 to -1/2, and then what else do we have here? -1/2 to 0. And throw in those asymptotes, those x cannot equal 0. Just throw those in anyway. X cannot equal -1. Okay, now we're finished. Please just get started on your homework. Thank you very much for listening. Good night.